And now we're recording. Okay, lecture 29. This one is going to be about sequences. Okay, so let's start off with a couple definitions. First thing we're going to define is the word sequence. Okay, a sequence, all a sequence is an ordered list of numbers. An ordered list of numbers. Okay, so one of the sequences we can have is, let's say we go all the way back to the beginning and we say, the natural numbers. Let's look at those. So the natural numbers are going to be the positive whole numbers. So 1, 2, 3, 4, and so on. We're going to be looking at sequences like these today. The natural numbers, of course, it's a number set, but it's also an ordered list of numbers. And it has some pattern to it in that you have to add 1 each time. So to get from one number to the next, you're adding 1. You're adding 1 every single time to get to the next number. Okay, so that's a sequence. And what we're going to be doing is we're going to be looking at terms next. All right, so let's define term. Okay. Term. A term is going to be a certain number in a sequence. And a term is going to be listed in terms of order. So for terms, you're going to have A1, that's the first term. You're going to have A2, that's the second term. And then you're going to have A3, that's the third term. And then A4, that's the fourth term. And then it just goes on like that. So looking up here, which one is going to be A1? Well, for the natural numbers, A1 is going to be this one right here, since that's the first term. And then what's A2 going to be? A2 is going to be the second term. That's going to be 2. And then you have A3 right here, and you have A4 right here. So those are called terms. Those are just every single number in the sequence. All right. And a quick little note that I wanted to do. So here's a note about sequences. Some sequences do show patterns. Some sequences show patterns. and some don't. So you can have some sequences showing patterns, right? Like these natural numbers. They clearly show a pattern that to get from one number to the next, you have to add 1 each time. But you can also have sequences that don't show patterns. And I'll give you a quick example of that on the next page. Okay, so what's an example of a sequence that doesn't show a pattern? Let's look at this one. So what sequences don't show patterns? One of them would be 3, 1, 4, 1, 5, 9, 2, 6, and so on. These don't really show any pattern. And the reason why is because these are actually going to be the digits of pi. And since it's an irrational number, it's not going to show a pattern once you get to the digits. Okay. So there are some sequences that show patterns and there are some that don't. So do be aware of that. Okay. And the last note that I wanted to write about sequences, the last thing I wanted to say was sequences can be finite and infinite. So sequences can be finite, meaning they actually have an end, or they can be infinite, which means they don't have an end. So an example of a sequence that could be finite, let's say the first 5 natural numbers. 1, 2, 3, 4, 5. Since this ends in a 5, this is called a finite sequence. But if you wanted to list all the natural numbers, let's say we get to 5 and we have a ... after that, this one is going to be infinite. So that's the difference between a finite sequence and an infinite sequence. And most sequences you've seen up to this point are infinite. But finite sequences are going to terminate at some point. All right. Let's go on to the next thing that I want to talk about, arithmetic versus geometric. Arithmetic versus geometric. Okay. Let's define arithmetic first. All right, so what is an arithmetic sequence? An arithmetic sequence is a sequence which contains a pattern. A sequence which contains a pattern. Where a fixed amount. A fixed amount, which is called the common difference. And we're going to label that as lowercase d. Is added. So it's going to be added to get from one term to the next. To get from one term to the next term. Period. Okay. So let's look at an example of what an arithmetic sequence would be. So this is going to be a sequence which is typically an infinite sequence. And what's going to be happening with this is we're actually going to be adding a number to get to every single term. So let's take a look at this. Let's say we have a sequence that starts off with the term 3, and then it goes up to 8, and then it goes up to, let's say, 13, and then it goes up to 18, and then it just keeps on going in that pattern. So looking at this sequence, we start off with a 3, and then we go up to an 8, and then we go up to a 13. What's the pattern here? What are we adding to get from one term to the next term? To get from 3 to 8, what are we doing? We are adding what? We're adding 5, right? So that means the common difference, that lowercase d that I was talking about, this d is going to be a positive 5. Okay? So we're basically just adding a number to get to every single next term. Okay? I'll leave that up there for a little bit, and then we'll move on to geometric. And we'll look at why geometric is so different from arithmetic. But for these sequences, they're called arithmetic because you're adding something to get to every single term. You can add a positive number. You can add a negative number, which is the same thing as subtracting, by the way. Or you could add 0, which means you're not really changing anything. So you just stay on the same term every single time if d is equal to 0. So that's arithmetic. That's when you're adding. So I'm going to put a big old plus sign up here. That means we're adding. All right, let's do geometric. Now for geometric, you're going to be multiplying. So I'm going to put a times symbol right here. So a geometric sequence is a sequence which contains a pattern where a fixed amount, and this fixed amount, we're not going to call it D, we're going to call it R. It's going to stand for the common ratio. The common ratio, R, lowercase r, is multiplied to get from one term to the next term. So let's look at an example of this. 2, 4, 8, 16, 32, and so on. Okay. So the first term is 2, the second term is 4, the third term is 8, the fourth term is 16, the fifth term is 32. So we got them all in a list. So what is the pattern? What are we multiplying by each time to get to each next term? From 2 to 4, we got to be multiplying by 2. To get from 4 to 8, we're multiplying by 2. To get from 8 to 16, we're multiplying by 2. And to get from 16 to 32, we're multiplying by 2. So if we're multiplying by 2 each time, that means R has to be equal to 2. That's going to be the common ratio. So that's a geometric sequence. We're just multiplying by a number every single time. Okay. Let's go over some formulas. Okay. Now, to find D and to find R, here's what we're going to be doing. Let's say you're given a sequence. Let's say A1, A2, A3, and so on. Let's say you want to figure out what D is, what you're adding each time. Well, if you want to find that, what you have to do is you have to subtract. You need to start off with your AN plus 1, and you need to subtract your A of N, and you'll get what's known as D, the common difference. So what you're actually doing is you're subtracting the previous term. You're subtracting the previous term. So for this, D would have to be equal to A3 minus A2, right? But notice that's the same thing as A2 minus A1. You're just taking one term and you're subtracting the one that came before it. Okay? Now to find R, what you're going to have to do there is you're going to have to divide. So I'm going to take the AN plus 1 term and I'm going to divide it by the AN term. And that's going to give me R, my common ratio. Because we're multiplying by something each time, right? So I have to take one of the terms and I have to divide it by the previous term. So what we're doing is we're dividing by whatever the previous term was. So that's a quick way to figure out what R was. Okay, so going back to the previous slide that we did, we had a geometric sequence. We want to figure out what R is. Well, I would just take 8. I would just take any term I want and divide it by the one that came before it. That would be the 4, right? And what's 8 divided by 4? 8 divided by 4 would be positive 2, right? So I'm dividing by the number that came before it to figure out what R is. So that's a quick way to figure out what D and what R is. Okay. So now let's look at some nth term formulas. Nth term. So what if I gave you a sequence? Let's make it an arithmetic sequence. Let's do 3, 8, 13, and then 18, and so on. And I ask you, what is the 97th term of this sequence? What is the 97th term in this sequence? Because I know what the first term is. It's 3, right? I know what the second term is. That's going to be 8, right? But if I keep this pattern going by adding 5 each time, what's going to be the 97th term? Is there a quick way we can figure it out? And the answer is yes, there is a quick way to figure this out. It's the arithmetic nth term formula. So if you have an arithmetic sequence, what you're going to be using is this formula right here. It's going to be AN equals, and remember AN stands for nth term. It's going to be equal to the first term plus n minus 1 times d. N minus 1 times d. And that n minus 1 has to be in parentheses or it's not going to work. This is called the arithmetic nth term formula. And let's say you have a geometric sequence instead, which we'll look at later. The geometric formula would be, it's going to be pretty similar. It's going to be AN is equal to A1, which is the first term, times R to the n minus 1 power. To the n minus 1 power. That's going to be my geometric nth term formula. Okay. So let's figure this out. What's the 97th term of this sequence? Well, what am I adding by each time? That's going to be the difference, right? What am I adding by each time to get from one term to the next? I'm adding by what? 5, right? So let's take a look at that. Now, because I'm adding, I'm going to be using the arithmetic formula. So I'm going to be using AN equals A1 plus n minus 1 times D. So what's my AN? Well, I don't know what AN is yet, so I'm just going to leave it the way it is. Okay? This is actually going to be my answer at the end. What's A1? Well, A1 is going to be the first term, right? My first term is 3. And what's my n? Well, we're going to fill that in later. So I'll leave that as n minus 1. And then what's d? That's going to be what we're adding by each time, right? That's going to be 5. Okay. So now what's n going to be? That's going to be the number that I'm trying to find, the 97th term. So n is going to be 97. And everything else is going to stay the same. So I'm going to have a 3 right here. My n is going to change into a 97. So I'm going to have 97 minus 1 times 5. So now I've got all numbers, and that means I can work it out. So the first thing I do is I do 97 minus 1. And what that's going to give me is that's going to give me what? 96 minus 1. What would that be? 96, right? So I'm going to have 96 times 5 plus 3 at the very end. So what's 96 times 5? That's going to give me 3 plus, let's see, 6 times 5 is 30. So I'll carry the 3. 9 times 5 is 45. Plus 3 is 48. So 480. 480 plus 3, that's going to be 483. And there's nothing left I can do to it, so I think I'm done. 483. So does that make sense to you? So I'm taking this sequence and we're projecting far out into the future. What is the 97th term going to be? That's going to be 483. Okay. Let's look at a geometric sequence. A geometric sequence. So this time we're going to be multiplying instead of adding, right? Let's take a look at an example of that. Okay. Let's say we start off with 1 over 16. That's a fraction, I know. But next we're going to have 1/8. And then we're going to have 1/4. And so on. And then somebody asks, what's the 10th term going to be? What's the 10th term going to be? Well, we could continue this pattern 10 times, and we could easily figure out what the 10th term is going to be. But let's use the formula and figure it out. So a1 times r to the n minus 1. I know this sequence is geometric because we're multiplying by something each time to get to every single term. So what are we multiplying by to get from 1/16 to 1/8? We're multiplying by something, right? Whatever that something is going to be, that's going to be our r, our common ratio. So what are we multiplying by? We're multiplying by 2. Multiplying by 2. So we're going to let our n be 10 this time because I want to figure out what the 10th term is. I know that our first term is a1, and that's going to be 1 over 16. That's our first term. And then what's r going to be? Our r is going to be 2. Right? and we need to raise it to the n minus 1 power. But what we have to do is we need to figure out what n is. And our n is going to be 10, right? So I'm going to replace this n with a 10. Okay, so I've still got 1 over 16. I know that 10 minus 1 is going to give me 9. So I need to figure out what 2 to the 9th power is, and I need to multiply it by 1 over 16. Now, we know that 16 is 2 to the 4th power, right? But since it's in the denominator, I need to keep it in the denominator. So I'm going to have 2 to the 9th on the top. I'm going to have 2 to the 4th on the bottom. And if I write it this way, you can easily see how the exponents are going to subtract to give me 5. And I know that 2 to the 5th power is a little bit easier to figure out. That's 2 times 2 times 2 times 2 times 2, which is 32. So all I'm doing is now I'm feeding it into the formula. I need to know what my first term is. That's this A1 right here. I need to know what my R is. And I need to know what N is. And even if you have an arithmetic sequence, you're still going to have the same stuff that you need to plug in, right? You're still going to have A1, which is the first term. You still need to figure out what N is and what D is, the common difference. So let's look at a couple problems from the problem set, because these are going to be the same types of problems that you're going to see on your classwork. All right. The first question is what I like to call find the next 3 terms. Okay. Let's say I got 10, 5, 0, -5, blank, blank, blank. So what I need to do is, given any sequence, I need to figure out what the pattern is so I can find out the next 3 terms. So what's the pattern for this sequence? Am I adding or am I multiplying? Right? Let's not think of subtracting and dividing. We're not going to think about it that way. We're only going to think about it in terms of adding and multiplying. What am I adding to get from 10 to 5? Would it be a positive number or a negative number to get from 10 to 5? It would have to be a negative number, right? So I'm subtracting 5 each time. Subtracting 5. So if I subtract 5 again, I'm going to get -10. Then I'm going to get -15, and then -20. So for these types of problems, we're just filling in the blank. We're determining what the pattern is and trying to figure out what the next 3 terms are going to be based on that. Okay. Now, sometimes they give you a formula. What if they give you a formula like this? How would I find the next 3 terms? So what I'm going to do is I'm going to find the first term, the second term, and the third term, just based on the formula. So if I give you this formula, what's the first term going to be? what am I plugging in for n? I'm plugging in 1, right? So if I plug in 1 for n, what do I get? 3 times 1 minus 2. Wouldn't that be 3 minus 2 is 1? So that's my first term, 1. And then if I plug in 2, what's the second term going to be? 3 times 2 minus 2. That would be 6 minus 2, which is 4. And then what would my third term be? Well, I just plug in a number. 3 times 3 minus 2, that's 9 minus 2, which is 7. So what's the pattern here? What am I adding each time? I'm adding 3 every single time to get to every single term. So if I was to find the next 3 terms, I would just add 3, right? So 7 plus 3, that would be 10. And then I would get 13. And then I would get 16, and so on. That's the way the pattern is going, based on the formula. Okay. So then what's going to happen is you're going to have to classify it. I'm going to give you a sequence, and you're going to tell me whether it's arithmetic or if it's geometric. Or it could be neither, right? It could have no pattern at all. So let's look at this next problem that I have. Classify as arithmetic, geometric, or neither. All right, let's say we have a sequence 14, 24, 34, 44, and so on. Would this be arithmetic, adding? Would it be geometric, multiplying? Or would it be neither? Well, since we're adding 10 each time, that would be arithmetic. So you would just write arithmetic. What if I was to give you 4, 16, 64, 256, and so on? What would this sequence be? Well, since we're multiplying by 4 each time, that would be geometric, since we're multiplying. Right? This would have to be geometric. And then what if we had the sequence 1, 5, -2, 8, 7, 0.5, and so on? What would this sequence be? Well, since there's no discernible pattern to it, this one would be neither arithmetic nor geometric. So you would write neither. So you need to be able to classify sequences. Are you adding? That would be arithmetic. Are you multiplying? That would be geometric. Or are you doing none of the above? That would be neither. And then the last types of questions that you're going to see are going to be finding out what D and R is and figuring out what the nth term is going to be. So let's look at the next problem. This one is find D or R based on the sequence. So let's say we have 9, 109, 209, 309, and so on. Find D or R. Well, if I'm adding to get to the next term, like I'm pretty sure I am, I'm adding 100 every single time. Well, this one is going to be arithmetic, which means I'm going to have to use D. D stands for the common difference, right? But let's say I have a sequence like 1, -3, +9, -27, +81, and so on. What am I doing here? What am I multiplying by? I'm multiplying by a -3, right? So in this situation, since it's a geometric sequence, I'm going to be multiplying. I'm going to have to use the letter R. R is going to be -3. Okay? So you need to be able to find D or R no matter what sequence they give you, whether it's arithmetic or whether it's geometric. Let's say they give you -16, -19, -22, -25. Find D or R. So to get from -16 to -19, and to get from -19 to -22, what am I doing? What am I adding? I'm adding a -3, right? One of the ways we can figure this out is we can take any term and subtract the one that came before it. So let's take this -19 and let's subtract -16. Well, since there's a double negative right here, that's the same thing as adding a +16. So this would be -19 plus 16. That's going to be -3. So D would have to be -3. So that's how you can find D. And for R, you can always divide. So let's take 81 and let's divide it by -27. Well, if we divide by -27, what are we going to get? You should get -3. So if you don't know what it is, you can always divide or subtract by the one that came before it. So that's finding D and R. And that's going to be based on whether your sequence is arithmetic or if it's geometric. So you need to know that too. Okay. And then going on to the last type of problem, you're going to have to find the nth term. So let's do two of these. Let's say I have 33, 36, 39, 42. And what I want to do for this one is I want to find the 11th term. So I want to find the 11th term of this sequence. Am I adding or am I multiplying? Well, I'm adding, right? I'm adding 3 each time. So when I go to my formula for the nth term, and I'll write it out so you can see it, I'm going to let D be 3. So I'm going to get A11. Since my n is going to be 11, I'm trying to find the 11th term. I know my first term is 33. My n is going to be 11. and the d is going to be 3. So now I know enough numbers to figure it out. First I do what's in parentheses, I get 10. We're going to multiply that by 3 to get 30. So I'm going to have 33 plus 30, and that's going to give me 63. So that's the 11th term of the sequence. Does that make sense for the problem? You start with 33, you add 3 11 times, you should get to 63. If we go on to a geometric sequence, can we figure that out? Let's say I have 1/2, 1, 2, 4, and I want to figure out what the 10th term is. Well, what am I multiplying by each time? I'm multiplying by 2, right? So when I get to my formula, and I'll write it out so you can see it, I'm going to already know what R is. Now my N is going to be 10 because I need to find the 10th term. I know that A1 is my first term. That's going to be 1/2. And then I just go from there. 1/2 times 2 to the 10 minus 1 power. So 10 minus 1 is going to be 9. So now I've got 2 to the 9th power on top. And all I have on the bottom is going to be this 2 right here. So this is going to be 2 to the 8th power, which is what? How many 2's? 8. So if I multiply all these together, these 4 are going to give me 16. These 4 are going to give me 16. And 16 times 16 is what? Carry the 3. 0, 6, 1. 256. So now that you know enough numbers, you can just put them into the formula and then figure out what you're going to get. So that's my geometric nth term. Okay. Now I have a few minutes left. I did want to do a couple more notes. So let's talk about alternating sequences. What's an alternating sequence? We're going to be looking at that next. An alternating sequence is going to be a sequence which alternates between positive terms and negative terms. So this is the kind of sequence that's going to start off with a positive number, and then it's going to go to a negative number, and then back to positive. So let's say -2, +4, -8, +16, -32, +64, and so on. I go from negative back to positive, back to negative, back to positive. And it doesn't matter how you start, whether that one is negative or positive, but it's just that you switch the signs every single time. So for this sequence, what am I multiplying by? I'm multiplying by what? A -2, right? So if you have an alternating sequence, it's always going to be what? Geometric. And my R is always going to be a negative number. We'll say -A. It's always going to be some kind of negative number that you're multiplying by. So R is always going to be negative in an alternating sequence. So whether you start off on a positive number or a negative number, it doesn't matter as long as you switch the signs each time and you're multiplying by something consistently, then you're going to have an alternating sequence. Let's say we have 3, -3, 3, -3, 3, and so on. What would my R be in this scenario? My R would be, what am I multiplying by? -1? Yeah. So that's that negative R term coming back in. And then we're going to look at one last sequence. Fibonacci. Okay. Fibonacci sequence. This is going to be the sequence Fn, that's a capital F, lowercase n, Fn of numbers where each number is the sum of the previous two numbers. Okay, so what does this look like? Well, let's start off with the first term. The first term is going to be 0. The second term is going to be 1. So we know what the first term and the second term is. So what's the third term going to be? Well, what I'm going to do is I'm going to add these up. I'm going to add these up to get 0 plus 1. That's going to be 1, right? And then what's the fourth term going to be? Well, I need to add these two terms next. And I get 2. And then I need to add up these two terms to get to the fifth term. That would be 1 plus 2. That's 3. So what would this sequence look like? it would be 0, 1, 1, 2, 3. And then what would the next term be? Well, 2 plus 3 is going to give me 5. What would the next term be? 3 plus 5, that's going to give me 8. And then what would the next term be? 5 plus 8 is going to give me 13. 8 plus 13 is going to give me 21. 13 plus 21 is going to give me 34. And then if I add 21 and 34, that's going to give me 55, and so on and so forth. So I'm adding up the last two numbers. So for this sequence, what I'm doing is I'm taking two terms and I'm adding them up to get to each successive term, right? So what I'm doing is I'm taking the nth term to be the previous term, the n minus 1 term, and I'm adding it to the term that came before that, right? The n minus 2 term. So every single term is going to be the sum of the previous two. Now, if I take these numbers, what were they again? 0, 1, 1, 2, 3, 5, 8, 13, 21, and so forth. If I divide them, like let's say I do 2 divided by 1, that gives me 2. If I do 3 divided by 2, that's going to give me 1.5. If I divide 5 by 3, okay, I'm treating this like it's some sort of geometric sequence, which it's not, but let's say I divide the terms, right? 5 divided by 3, that would be 1.6 repeating, right? What if I did 8 divided by 5? Well, that would be 1.6, right? And if I did 13 divided by 8, I would get some different decimal, right? Well, it turns out the higher the numbers that they get, if I keep on dividing them, I'm going to reach this number called the golden ratio. The golden ratio. And the way that it's often put is the golden ratio, which is this weird Greek letter, it's actually equal to the limit of one term divided by its previous term as n approaches infinity. So that's an interesting way to think about it. If I keep on dividing, the biggest number by the one that came before it, eventually I'm going to get close to a certain decimal called the golden ratio, which is like 1.61803 ... It's this long decimal. It's going to be called the golden ratio.